Now quickly answer these questions. We will keep moving. Where this rotational motion, the fundas of that. Okay, right. On account of the Earth rotating about its axis, the linear velocity. Please answer conceptual questions. Okay, what is the option?
Option A is correct.
Obviously, there is only one option that is possible. Understand? I don't know why Aditis and Anushris and Prabhus and Saurabhs, even this question they don't want to answer. God save them. Even this question you are all keeping quiet. So here you see at the equator, the linear velocity will be more, angular velocity everywhere will be same, right? So therefore, the option is A. Yes. Right? Okay. Right.
Sir, here we are considering art to be perfect space.
What should I tell you, man? Why you want to think otherwise? I don't know.
Sir, they have just said Earth, sir.
Yeah, you should always think like Earth is sphere only, man. Unless they are unless explicitly told.
Yes, sir, yes.
What yes, man? You exam rago hinga ಮಾಡ್ತೀನಿ And don't ask me what is flywheel. We have done a lot of problems in rotational mechanics. Right? Flywheel means, in your cycle you have that hind wheel. Hind wheel there is a sprocket. Okay? That acts like a flywheel. Flywheel means you give some momentum to that, some kinetic energy, it will be rotating. And then if you stop pedaling also, it keeps rotating. So that the kinetic energy that you have imparted, the work that you have done has got converted into kinetic energy of the wheel, and that wheel keeps rotating. So flywheel is meant for that. So all the basic equations, whatever they have used, the same equations have to be used here. So basic equations for those of you who have come unprepared. Alpha t, okay. So omega square minus omega naught square is equal to 2 alpha theta. Okay, these basic equations. Or theta is equal to omega naught t, okay, plus or minus half alpha t square. Same set of equations. Okay, we can use any of these equations to solve this problem. So here what is written here, it is an angular velocity, omega is given as 36 units and the time is given as 6 seconds. The total angle through which it turns in 6 seconds. So they are asking the theta. Okay, and it is starting from rest. So you just have to use this equation. But of course, they are not given alpha. So you have to determine alpha for this equation. They are giving you 6 seconds. So 36 by 6 should give you 6 radians. Okay, so then directly theta is equal to half into 6 into 6 into 6. So cancels. So 6 6 are 36, 36 6 are 108 radians. So you have an option. You have an option. Okay. These are all just basics. I'm just giving these problems so that you brush up. A rod starts rotating from rest, acquires rotational speed. N is equal to 600 revolutions per minute. N is equal to 600 means omega will be equal to by per minute divided by 60. So if you divide by 60, you will get 10 2 pi. 10 into 2 pi radians per second. See, they have given revolutions, number of revolutions. You have multiplied by 2 pi with constant acceleration, the angular acceleration of the rod. Okay, and the time they have given us 2 seconds. Time they have given us 2 seconds. Okay, quite simple. So alpha will be equal to, okay, what 10 into 2 pi divided by 2. Is it? So this is the answer. So we will get 10 pi, okay, radians per second. Okay, friends. See, I am just taking very simple sums so that it should be a warm up. Some of you would have come fresh. Here you teach, you will do it. These are all things, nothing to teach here, because for solving any problem in electrostatics, magnetism, etc., these basic equations are necessary. And you are having every monthly test in your college where they are using all the first year portions are also there. So I suppose that you are familiar with all this. But still, I am taking some questions here. Simple questions so that you get fresh in. Okay. Can you read this? Not possible. Wait. Okay, you read it? Yeah. Number of resolution 60 centimeter diameter of wheel can turn the car. So in one revolution it will form pi d. In one revolution. So in one revolution it will form pi d meters. So you have to convert this 60 centimeters into this. That's what you have to express in this. So you get here that is 0.6 into pi. Okay, what is this? Meters. So therefore, how many rotations you should do for 2.5 kilometers? That is 2500 divided by 6 pi. Into put one more zero there. So you'll get 6. So approximately you can take it as 25,000. 6 pi is 6. If you take pi as 3, it will be 18. So this will be 18 1 by 18, 70. 70 is close to 14. So close to 1400. So something less than this. So when the option is this, C should be the option. Okay. So this is how you should quickly solve such sums. Okay. Got it? If anybody has any question, you can ask. gears are meshed means two gears are connected like this. One gear turns, other gear turns. Have radius of so and so, so and so. Okay? The number of turns smaller than the. So if you don't remember the theory, you can draw. If you don't remember the theory, you can quickly draw this for your convenience, the smaller one and a bigger one. So this is R1 and this is R2. So this makes one revolution. So here 2 pi R2 revolutions, that this is for one revolution, but this will make 2 pi R1 revolution. So 2 pi R1 revolution means this will say move from this to this. Therefore, number of times that this should turn, so that this should turn once, will be what? 2 pi R2 divided by 2 pi R. Simple. Hello?
Yes, yes.
This will be the number of revolutions that this has to do. That is, X will be what? The number of revolutions the smaller one has to do, if bigger one has to do one revolution. So in this case it is 3. So R2 is 15 by 15, okay, into 3. You have to do 3 was the 3 pi the 5 times 5 times. That has to do 10 revolutions. Clear? Huh? Hello? See, if anybody is having any difficulty, you can ask. I am giving you very simple sums so that it should be a teaser to begin with. The radius of the wheel is 0.4. The car is accelerated. Very simple. So the formula from this will be 1.5 radius alpha into t into 20. So this gives you 30 radians per second. Okay, and then there are linear velocity. V is equal to omega. 30 into radius is 0.4, 4 by 10. So that gives you before the 12 meters per second.
Yes, sir.
See, I have chosen this problem as a refresher, but what is important, you see, I am reducing the number of calculations. See, here it is 1.5, I wrote it as 3 by 2, and here it is 0.4, I wrote it as 4 by 10. You see, calculation becomes very simple. Otherwise, you start multiplying those things, life becomes difficult. Shall I proceed?
Yes, sir.
Okay. The moment of inertia of the triangle should be greater. This one, aram se, if you know moment of inertia, you can aram se solve it. If you don't know, you ask me, I will teach you the theory. If you ask, I suppose you also already know the theory. So moment of inertia will be more if the mass is distributed very far off. Understand? The distribution of the mass is very far off, because it is what moment of inertia is integration. Moment of inertia is integration dm r square. So the larger the distribution of mass from the axis, or the proximity of the mass distribution with respect to the axis is more, then the moment of inertia is more. Okay. So obviously here you see this rod length. This rod length is small, this is big. So this is small means then this distance of this from here is large. or you can convert this triangle into a rectangle. You can convert it into a rectangle, okay? And if you take only this much, right, then it is going to be half of it. So therefore now it is now AB. So if you see AB, if you have taken a rectangle, then definitely this is more, isn't it? Because the distribution of mass, see, this mass is distributed at a larger distance from this. But if you take this axis, the distribution of mass is lesser, the proximity is lesser. And of course, this means it is the least because the distribution of the masses are very close to this line. So therefore, I will go with AB. And of course, I have taken a rectangle, and if you take a triangle, it should be the moment of inertia should be half of it. Clear? Huh?
Yes.
Nearly half of it. Nearly half. Not exactly. Okay? So I will go with this AB. Okay? Hello?
Yes, sir.
Huh.
Yes, sir.
What's the time? I should not exceed. Wait, I told only 8:30, no? Okay. Okay. I think I should stop the class. It is 8:21.